7, it says the fountains of the deep were broken up and the windows of heaven were opened. What I think happened to cause these magnetic anomalies down there, the fountains of the deep broke open. The Bible says there was more water under the crust of the earth. We'll get into more of that later. When that water came shooting out to the surface, the earth ripped like seams on a baseball, and the crust above went sliding away, opening up a crack. As the water came shooting out, it would widen the crack and slide the continents away. They would be sliding down. As they slid down, the underneath part would bulge up. Now the sublayer is called basalt. As it bulged up in the crack, it would develop cracks in it, or fissures, which are going to fill in with water. Water's going to rush into the crack. Now the neat thing about basalt, if it's very hot, it doesn't store a strong magnetic signature, whereas if it's cooled off, it stores a stronger magnetic signature. So all they were measuring was where the cracks are in the Mid-Atlantic Ridge, stronger and weaker magnetism. They weren't measuring reversals. There aren't any reversals down there. The magnetic field does not reverse. There is no place on the ocean floor where a north-seeking compass will point south by the rocks down there. It just isn't true. So don't fall for that. The earth is cracked up. That's not the question. But it didn't happen slowly over billions of years. It probably happened during the flood. And the textbooks are going to say that the ocean floor is being subducted or recycled. This is also a very important part of the Pangea theory, and I'll tell you why. There's not enough mud in the oceans for billions of years of accumulation. See, when it rains, dirt washes off the hills and runs into the oceans. Eventually, it all ends up in the ocean. But there's only enough mud down there for a few thousand years worth of erosion. So it's kind of an embarrassing problem. You know, if the earth is billions of years old, why isn't there more mud in the ocean? So they come up with this theory of Pangea and the subducting of the continents to answer the embarrassing problem of where's the missing mud. They're going to say, well, it's being recycled. Well, I don't think so. Textbooks are going to say that the continents are moving away about as fast as your fingernails grow. Not too fast, right? There's no actual positive proof of this. There's some good theories, and the continents may be moving away. However, continental plate movement does not prove they've always been moving, obviously. It does not prove the rate has always been the same, and students should be told there are other options. There are some other options to explain this. I live just a few miles south of Interstate 10 in Pensacola, Florida, right there. Interstate 10 goes from Los Angeles all the way to Jacksonville. If I see somebody headed east at 70 miles an hour on Interstate 10, does that prove they started in Los Angeles 4 days ago? Well, no. They might have just got on at the last exit, right? And if you see the continents moving a little bit, that doesn't prove they've always been moving. They might have just started at the time of the flood in the days of Noah. Continental drift theory is important for the evolutionists because they're trying to avoid two embarrassing problems. Number one, the magnetic field of the earth is getting weaker, indicating less than 25,000 years for the age of the earth. So they have to get an answer. They'll say, well, it's reversing itself. No, I'm sorry, it is not reversing itself. Don't fall for that, okay? The simple fact is the earth is not millions of years old. Secondly, there is very little sediment in the ocean, indicating only a few thousand years of accumulation. So that's why the continental drift and Pangea theory is really pushed on these kids, not because the theory is reasonable, but because it answers some embarrassing problems and keeps them able to believe the earth is billions of years old. Now what about the Ice Age? Was there ever an Ice Age? I mean, did the ice come all the way down to Kansas City, Missouri? Oh yeah, there really was an Ice Age, folks. Well, where does the Ice Age fit into the Bible? And what froze the mammoths? The big, huge, hairy, hippie elephants that are found frozen. Some of them are standing up. Food still in their stomach, food in their teeth, undigested. What happened to the mammoths anyway? Well, I got curious about these mammoths. You know, in 1 year, I heard they took out 20,000 pairs of tusks. They go up there and dig them out. They call them ivory mines. Nobody knows for sure how many mammoths perished, but many experts estimate it could have been as many as 5 million mammoths perished around the polar regions. We find them all over in Florida. Of course, they're not frozen down there. They're petrified or coalified. But up around the North Polar region, some of them are still frozen. How many saw the news a couple weeks ago when they got the big giant mammoth completely intact and took it out of the ice? They're going to try to get mammoth DNA and clone it with an elephant or something. I hope they do. It'd be neat, okay? It wouldn't prove evolution, but it would be a neat thing. But what about these mammoths anyway? What is the truth about this? They're found all over Siberia and Russia and Alaska, what happened to the mammoths? Well, the mammoths are frozen upright. A few of them are, not all of them. Their undigested food is still in their stomach and in their mouth. They died of suffocation. There is no water found in the lungs, so don't let somebody tell you they fell into a river and drowned. That is not true. First place, if you fall into a river, you don't freeze solid into a block of ice. It takes a long time to freeze because it might be 50 below outside, but once you get under the ice, it's 32 degrees. So they're not going to freeze. Next, there's small ice crystals in the blood indicating they probably froze in less than 5 hours. If they would have frozen slowly, the crystals would be bigger. So how do you freeze an elephant in 5 hours? I got curious about this, so when I get curious about something, I don't know any better than to start asking questions. I called everybody I could think of that might have an answer. I wanted to see how long it would take to freeze an elephant. So I called Bird's Eye Frozen Food people in New York. I really did. I called up, talked to one of the scientists there. I said, hello, sir. If I stuck an elephant in the freezer, what would happen? He was silent on the other end of the phone for a few moments. Finally, he said, you'd have a crowded freezer. I said, well, yeah, I know that, but how long would it take to freeze an elephant? He said, well, meat freezes about 12 inches every 24 hours. And what's going to happen if you stick an elephant in the freezer, the outside is going to freeze and the heat is going to be trapped inside and the middle is going to rot out because the heat is trapped with an ice insulator around the outside. I said, well, that's not going to work because the mammoth I want to freeze, the elephant, I got to keep the food in his stomach still green, still fresh. And after he's dead, the stomach acid doesn't know he's dead. It's going to keep working. And so I need to freeze him in less than 5 hours. And I called physics professors and meat packing houses and Bird's Eye and everybody I could think of who might know. And the consensus of opinion was that if you want to freeze a mammoth in less than 5 hours, you have to put him in something about 300 below 0 Fahrenheit, like liquid nitrogen. Well, it never gets 300 below 0 here on Earth. I've got the map of the South Pole from National Geographic over here. The coldest temperature ever recorded is minus 127. That's pretty chilly, but that's not cold enough to freeze the mammoths. Where do you get something 300 below 0? Well, tonight I'm going to give you the Hovind theory of what I think happened. Now, I have to give credit to lots of other people. I've read so many different books from varieties of opinions on what caused all these things to happen. I've tried to put it all together into one theory that makes sense to me. Now, maybe you got a different theory. I'll listen to any theories you got. I think what our job is, since this is a one-time past historical event, we can't prove any of it. We put the pieces together and develop a theory and see if it fits. So let's look at the Hovind theory tonight and see if it fits. But before I give you the Hovind theory, I need to review some science. There is a law in physics called the inverse square law, which basically says if two objects are attracted to each other, like two magnets or two planets with gravity pulling them together, the force of attraction is inversely proportional to the square of the distance between them. In English, that means if you would half the distance, you would quadruple the traction. See, the Earth and the Moon are pulling on each other with gravity. If you brought the Moon into 1/3 the distance, you would take that 1/3, inverse it, and square it. It would be 9 times the gravitational pull at 1/3 the distance. Inverse square laws apply when you're dealing with forces involving gravity, light, magnetism, and girls. When the distance is halved, the attraction is quadrupled. Now see, I travel every week. I've been home 5 Sundays, I believe, in 10 years. I travel a lot, which means I get to come home every week. And when I get about 20 feet away from my wife, it's, hello, dear, how are you doing? When you half the distance, it's, wow, you looking good, honey. When you half the distance again, it's too late. So the secret, fellas, is stay about 20 feet away, and that'll cause most of the problems to disappear. This is the inverse square law. Okay, the next thing to keep in mind, a spinning top behaves in a very particular way. Okay, if a spinning top is struck by something, it'll wobble around and it'll recover spinning smoothly at a new angle. But as it wobbled, it followed a very predictable pattern. You can actually determine when a spinning object was struck by looking at the wobble that it does. If you graph it out over time, you can say, well, it was impacted about right there. Interesting, okay?